Hello everybody and welcome to today's tutorial. And we have been doing a lot of things. We have been doing a smart job when it comes to hardware development and PCB design. And today I'm going to take you through another fascinating project which is very interesting and very wonderful, whereby we shall be developing a mini board using 8051 microcontroller. And I welcome everybody on board. It's a programmable logic, but for today we shall be doing the hardware only, and then programming might be done in another video. Thank you and welcome. Feel free to ask questions in the comment section of this video, and we shall be replying to your questions according to how they come, and with great expertise that we have. So let's get started. And today I'll design the circuits very quickly, and then I will explain them later. But before that, we can begin from searching the microcontroller. I had searched one. The 8051 microcontroller is here, and this is how it's connected. So we shall be getting most of our circuits from here. We can see it's powered by 5 volts. This means that we have to start with the power management circuit, or the power circuit, or the power section, whereby we shall be doing a circuit of 5 volts power in order to power our system. So let's get started by designing the power circuit. So we close this. This is a previous project that I was doing, so we close it. Yes, save. Okay, now we start. We go to file, new project, and then we save it where we want it saved. Articles, we'll save it in new, then I'll open a new file here, and name it 8051 mini board. Then we open, and here we shall start our project. 8051 mini board. Okay, then we save. Then we start the schematic. So we have said we will be doing power management circuit at the beginning, so we get started as quick as possible. And to get started, before we do anything else, we can edit this schematic. We'll write the title 8051 mini board. Then I can write my name as company name. That's all I need, which is important. Then the date of the design, which is there. Then I hit OK. Control save. Now we start. We start very quickly. And here we are going to start with the power. We want to create a circuit of 5 volts, and we shall be powering it using a battery. So a battery might be giving us around 12 volts, so between 8 and 12 volts. Okay, and that's how we begin. So we begin with our input. So I'm going to input my first symbol. I don't want to go. So I will search my IC LM7805. I showed you how to look for these ICs. So I won't repeat again. So this one is better. Then of course I showed you how to connect it. It has some capacitors. So capacitor CP1. Okay, I need a non-polarized capacitor. You come here, but I need it small, like that. But I need a non-polarized, so C small. Okay. There, I can copy this one and then put it on the other side. Then I can put another capacitor which is now polarized capacitor. CP, but now small. Okay, I can still use the British symbols. like that. Then I can edit the values. Wonderful. Then here be wonderful. Then here value 100 microfarads. So one should be small. Okay, now we go to wire and wire all these. All left click, left click, left click, left click, Control save, and then we have to input some diode. So still I have to take the symbol escape and put some diode which is 1N 400. That is good. You can rotate it R for rotation like that, and then I input resistor, but I can use the US symbol small. Then LED will be our feedback, so LED small. This is our feedback for this circuit, so we can rotate it like that. Then we need to ground this system, so ground and okay, and copy. I can place grounds everywhere, all over these circuits. I don't need to utilize one ground to connect everything. Then you got wire now. We are almost there. Then you have to indicate that here we have an input of 9 volts, and then here we should be having an output of 5 volts of power. Okay. Then here we have 9 volts. 9 volts like this. Then we connect wire. Control save. Control save. So then I can add some labels here. So we can place text. Then you call it power section. Convert to volt. Like that. So that's our power section. This is where now we should be powering our IC circuit. And therefore, our board is ready to be powered by 5 volts. Then now you proceed to the next stage, which is now you place your microcontroller. Now you start doing the main thing of this project. Okay. So symbol is A shortcut. Then you come and search your microcontroller. That show you the microcontroller is here. The microcontroller that you are using, the item. This one is AT89C51. This is the microcontroller that you're going to do, or you're going to utilize in our the schematic. So let's go on. So 18, 9. So you want to look for the beta pins. The beta pins of this circuit. So pin 01 to pin 07, 1.0 to 1.7, that's all correct. Then we have pin 3. Let me look for another one. 88 and 9. So I have not found the symbol that I want. Therefore, I can create my own symbol by utilizing this bit. First, I'll create my own library. Add a library. Not adding. New library. Term 51 maybe. Save. It's save it to global. There's no problem. It's here, so I need to add my own. Okay, the symbol that I want to create is for the A team. 8951. I will call it 8951. Just drop 2. Okay, I can call it 8951. Just like that. Exposition, everything reasonable. Okay, move. Can move this one to there. Move the symbol to there. Then I can reduce this. Then I can come to grid settings. Okay, you can hear them. So you come to pins. Pin. So the pin length is 5.05, 0.08 millimeters. Oh, 0.1727. This one is correct. The first pin name is T2. Okay, but now The next pin is so pin 1, pin 1, pin 2. Pin 1.2. So you'll go like that, until you create your symbol fully. So now let's go on. Okay. 51. 51. .0 P 1.0 correct, 2.0 correct, 0.0 correct, not enough. This one 0.0 pin 1.0 correct, pin 3.0 correct, just more. .81, 18, 51. 1, 2, 3, 1, 2, 3, 1, 2, 3. Reset VDD. So we come back here, we check at it. What do you have? Correct. So we place our microcontroller there. Here we go. Then we can reduce it so that we can be able to do the connections. So what do we have again in our microcontroller? We have 5 volts. So we can carry this one copy, bring it somewhere there. You see where it is supposed to be. 5 volts should be at pin B0. So this one copy again. Bring it on this side. So we can wire this like that. Control C. So that one we have powered. Okay. But again we can try to look through. That's our PowerPoint. So in our reset clock, reset here, you can try to do a circuit for the crystal circuit. So you can do it here. Okay, we can do it here by introducing a crystal, static crystal quartz, but you can look for crystal small. Okay, for reset, then I can rotate it. I want to do it at once. Next to number 18 and number 19. Wire. We do the crystal quartz here. Control C. You can undo it. So let me check out the connection. You can see XTL and XTL. And those one, according to research, they are pin number 18 and pin number 19 and 18. Yep. That's where our XTR is. So we can check out capacitors. We can place capacitor in. Sorry. Then our capacitors. Now I can even decide to copy from here. Going to work with this one. We have capacitors here. We copy this polarized. I can use the non-polarized one copy. I'm showing you how to utilize the shortcuts in our systems. So copy again, place it there somewhere there. Then we have to ground them, so copy ground, place it somewhere there. So we are utilizing number 18 and 19 wire. So you wire. Okay, we can undo. We start with number 19. Click that on the number 18. Like that. You can rotate these ones to make it better. So you can delete this wire. You can delete this one too. You can delete this one. You can delete this one too. Then I can do the quickest connection now. This is the crystal quartz circuitry. Control C. Yeah, I've done the crystal quartz. Circuit is connected. So you can copy ground. Then we go where ground is. Ground is here. Control C. Okay. So before we proceed, let me check out another pin. Okay, the positive VDD. So you can copy this and move it to VDD. Control save. 1, 2, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9. The other one is 9 again. So what do? We import pins. So then you have to con. If we do that, let me try to see our resistor. So I need to press connectors. So 1 times 0.9 like that. Okay. You start here, rotate R. Okay, like that. Connect them. Wire. Control save. Then this one is busy, so I'll copy this. Copy. Rotate R. Control save. But I can rotate this one. X with X. Control. Save. Now we go to the next pin, so I can copy this one. Copy. Then we take it to this section and R for rotation. R. Can put it there so I can wire. So what do you do? And rotate R. So X. Control save. You're going well. And I did the final input. So for reset again, we have a circuit for reset circuit. So I'll input capacitor, copy this type of capacitor. Then in this type of capacitor, I will edit this. The value is 10 ohms. Okay. Then I will import a switch. Escape. Okay. I'll import a switch. SW. Which kind of switch is this? 1, 2, 3, 4. This one correct. This is the type of switch they have used there. Like that. On this switch, I'll connect 5 volts. So copy this, place it somewhere there. So this one, you go to wire, is connected to this point. Then number 2, this one is connected to this point. No, this is not the type of switch I should get. So I should press component here. The switch I've picked is wrong. Switch. SW. Okay, let's see. Switch 2. Okay, I can still use it, so there's no big deal there. I'll copy this, place it there, wire. This capacitor goes directly to press it from here, like that. Then it has ground. Then we have from ground this, come to this point. Where else? We have this to this point. Control save. Okay. But before ground here, so I can move this ground symbol to that point. Then I can add a resistor here. I can copy this resistor. Copy. Let's copy. See. And rotate it. What's the value of this resistor? 10K. So I can edit the value. 10K. Okay. What is the value of this resistor? Again, it's 10K, so I can edit by value. 10K. Control save. So I'm almost there. So what do I pick again? I need to pick some few things. These switches must be connected, all of them. I need another connector. For this circuit. Control save. I need this connector to copy here. Copy here. Place it there. Copy this power. Control Z. So you have to input arrays of resistors here, around 4.7. Okay, so we can copy this, and place it here. Then from there you can do what, you can edit the value to 4.7k. Okay, correct. Then now you start copying everything, copying. So what else do I need? To this one. So PSN, PSA. So there are some of the levels we have to input. pin 1.7. Pin 1.7 should be your reset pin. So you connect the reset pin 1.7 here. So you can insert label. Control C, RTD, and so on. So we have so many other labels, but now for a good expert, you have to go through the microcontroller schematics in order to understand some of this. So you have to understand the 8951 microcontroller, how it works, and so on and so on. But so far, we have all the basics that we need for this circuit to go on. So we can annotate the schematic, close, insert the netlist, generate, DSF. Then you go to BOM. You build our board. No, before you build our board here, oh no, you cannot build your board without adding shown of footprints. So we add the footprints to our schematic. We add the footprints to your schematic. We see the way forward. So as the footprints loads, okay. So here we have three sections in this microcontroller. I can explain this schematic a bit. Okay, we have some three sections which I've decided to break them into two sections. System clock. Okay, you have the crystal quartz here. System clock or crystal section. In 8051 clock circuit, a quartz crystal is used to make the clock circuit. The connection is shown in the figure, this one here. And note the section to XTL1 and XTL2. If serial communications are involved, then it is best to use the 11.059192 Hz frequency crystal quartz. Okay, we have the reset button here, connected again, which resets the 8051 when need be. Oh, I'm sorry. In fact, this is the reset section. Then the crystal quartz section is here. This one. In which a reset happens only when a push button is pressed manually above the circuit. Is used to reset the 8051 using push button power circuit, and so on and so on. Then we have this is the powering section. This powers the microcontroller. That's all about the circuit. So you can go on and add some footprints. So we'll start with capacitor. Okay, the large region. Sorry. Did it the wrong way. So you have the capacitor. So then the rest of the capacitors I will add them. I will add them 0805. Diode of this LED. the connectors. We'll use pin 2.0. For the resistors are SMD 0805, of course. And for the switch, so we go to no, before there, we generate the net list, generate, see, then you go to board now, and here now you load. Why is it? You update the net list, update 01 plus, you bring it there. No, I don't like the microcontroller here. Discard changes. I don't like the microcontroller footprint there. So we can come back here. I don't like the microcontroller footprint there. Why should it be like that? So, you know, why should it be like that? Got it. Layout systems. It to be long. So there we go. I'm gonna move these ones like that because I want to rotate these. So we are in PCB layout. Okay, we're in PCB layout. So J1, which resistors are related to J1. This is our J2. This is our J3. This is our J1. So I want to see which resistors are related. R4, R5, R6, R7, R8, R9 are related to J1, R4, from R4 to R. Okay. R4 to R7. R10 to R11. R4 to R4. R4 we are doing the arrangements of our system. Our system must be very nicely arranged before the routing process begins. The system should be very nicely arranged. Move, 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 move. Okay. Move, 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 R. 1, 2, 3, 4, 5, 6, 7, 8. Correct. This one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Move. Move. Now we are doing a clearance. So this one, we copy everything. Move. Rotate. Or. Copy everything. Move for this one. Or. Move. Move. save. It's getting shape. So we can move this one a bit, move to almost there. And we can go, oh sorry. Yeah. Then you can move this one again. Pick everything. Move. There. And you can move this one again. Move. There. And we try to view it. We see what we are getting. Okay, it's getting shape. It's getting shape. It's getting shape. I don't like the type of power supply which board is there. So I can just come back here and edit the footprints. So on editing these footprints, which one package? Yes, we go to package again. Not a bad one. So okay, then what do I do? Netlist, enter netlist, save. Then you come to this one, you update netlist, then you do close. Which press yeah. And it's better off than you are working with. You can see this IC has changed here, so it's better off. So the next thing is this IC move. Move. Let's switch. We want to make it as compact as possible. So that's why you can see I'm struggling to create more spaces. Make it as more compact as possible. Let me view first how it looks like. Okay, you can see it's gaining shape. High end 4000, so I can change the footprints of that one. I don't like the analog one, it's very big, so huge. So you come here, the circuit, you go to footprints. Okay, so you go to diode, lead to this one. You go to this side, the diode. Okay, diode SMD. Then look for this one. You click. Then netlist, right? Save. Then now you come back to our schematic. You update the netlist. Update. Then you close. You can see our diode has changed the size, so it's smaller. Move. 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 Come from here. Move. Move from here. Come here. Move. Or rotate. You can rotate it like that. LED. Okay. Then you can try to have this one move. Move a bit out. Give this one a space move. So you can try to move these ones upward. Okay, let's say there. You can move these one too. Let's say there. Move. 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 Move this one. These ones you can move them at once. Move, 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 and then move these ones. Like that. Move. Update her. Move. Now let's view again. Yeah, not a bad one. Not a bad. So we can draw the edge. Cut first. Okay. The edge cut will give us the size of the exact size. Let's view. Okay. This is it, but there is some few problem here. So you can undo that. You do the edge pattern actually. Like that. Then now you can view. Yep. I think this is nice. Okay, we have done it. Then you can do routing. You can see we have untitled 76. All these nets must be created, all these routes. So let me start routing very quickly. So what I do, I can try to rotate this. So you can enlarge it, then rotate. Okay, then you can try to copy this, like that. Then you can have the not copied everything. You can try again. Move. So what we do, I will mirror. Mirror. Okay, that's no problem. That's not a big problem. Big problem is doing the routing. Let's do the routing very quickly. We'll start from this one, go there, we'll come to the next one, it goes there, next one. I will not do all the routing, I'll do just a bit of it to show you how it's done, but the rest you will have to do them by yourself. So like this one, you don't need to force things. You use a VM, plus the VM, wherever, this video can be pressed somewhere else. Just when you place there, then you go again another view somewhere there, and then you finish up your. You can see, I've gone to the below board like that, and I have routed it. So you go to the next part again, a view. Wherever a view can be placed, you place it there. Wherever a view can be placed, you place it wherever it can be placed. So again, this one, you place over here. And so on until you get the right thing. So you route the first to be routed. Anything that is possible to be routed, you route very quickly. You start with the simplest ones to create over here as routes. You cannot use such a path. You cannot use that over here. Here, finish up like that. Again here, there. You go to this point here. You place it there. You finish up. only do the ones that are quick to be done. The rest, so you can see the unrooted 48, they are reducing at a very quick rate. You can see they are reducing at a very quick rate. 44, 43, 42, 41, 40. You go very quickly. You do the first things first. So I'm not going to do everything. I'm going to do just half of the roots. Okay, the rest you can practice by yourself on how to do the routing. Everything shall be routed. Now you're at 32. You started from 67. So you go on, you go on. Sorry, this one is wrong. So skip. Skip. So I can use a wire like that, pass through this. Then another wire, replace it together, and we finish up like that. Control. See. Via there, via there, connected again here, via there, like that, connected again, via there, again connected, via there, connected, via there, connected, via there. Oh, place it. Okay. Via there. Connected. Via there. Oh, I'm gonna put a via there. So we start via there, we go like that, via there. So how many are we remaining with? 18. So we are still doing a nice job. We are still doing a nice job. Via. Control 7. We have via. So how many remain? 16. You're still going. Control save. Okay, so I can leave it at that point. 15 are left unrooted, but at least I have shown you what you need to do. So we can try to check our view of board. Yes, this is our board. This is our board. So far so good. We can do some few final touches on the board, and these final touches involves things like adding of mounting holes. Yes, mounting holes. So we can add 2 mounting holes. Footprints. Can add only 2 mounting holes. So mounting holes, I like using with card. Okay, place the first one there. Again. Okay, I can place the last one here. Then we can view. You can see. Yes, the system is good. So we do the final bit of it, which is called addition of copper poles. So you come to copper poles here. We'll start with the green one. Copper poles. Okay, like that. Select on the ground. Okay. Then I do the copper pole. Like that. Like that. Like that, like that. Then you go to the final bit of it, which is the top layer. You can do the same thing again on the ground. Okay, so we select like that, like that, like that, and then like that. Then we control save. Then we can view again our board. Very good, very nice. So I can enlarge it. That's how our board looks like. You can see it. It's there. It's a nice board. And that's how to design your 8051 microcontroller mini development board using KiCAD IDE. Thank you everybody for your attendance and enjoy your design. Goodbye.